In this example, let's go back to our first Hello World program. We're going to use actually a pointer to a character array to end up printing out Hello World. Right? We all know how this one works now, right? If we run this, we get the message Hello World on the screen. We've also then seen a variation where we can put in the specifier here, %s for string, and then we know that here within the double quotes, this Hello World is a string. So if we were to build and run this, right, we get this string of characters, right? So %s, a string of characters, is nothing other than a character array. So we can get the same behavior here by going ahead and creating a char star, right? I'll call that message, right? And assign to it then this array of characters here. And here I'm just going to say use message, right? So substitute in message there, print that out. And we get our same result. All right, so this char star here, right, created an array of characters that was long enough to hold then each one of these characters, right? It automatically allocated memory. I can refer to that memory as message. When I do, the data type of a char star is a string. So data type of character array char star is a string, right? A string is simply a character array, or an array of characters. Right. Well, it's sort of a trivial example, but it's an example where you can now use in some sort of character array, right? You could create some of these arrays for certain messages and go ahead and pass those as strings. Right. Later we'll study special string library functions, but I just wanted to start out with that example. Right. Let's go ahead now and write another program, perhaps using floating point numbers. What if we write a program that adds two floating point numbers together? So let's create a new file. I'll just call this float add. All right. So we're going to, so the program reads two floating point numbers from the keyboard. And prints the sum of those numbers. All right. All right. We already know how to do this. Let's do it in a way that we already know how to do it. All right. So let's declare two floating point values. Float F1, F2. All right. And let's prompt the user to enter two float values. And then scanf. Well, we know for floats that this is %f to read two of these. All right, and then I need to give it the address of F1 and then the address of F2. Right, and then we could simply then, let's have a sum variable. It's of type float, right? I want to assign like types to like types. I could say sum, right, is equal to F1 plus F2. And now we can print out, in this case, the sum of, right, F. All right, so let's go ahead and print these out. Oh, let's just print them with 2 decimal places. %2f equals %.2f. All right, and now we're going to substitute in F1 for that first argument, F2 for the second, and then the sum for the third. And Let me maybe give this a couple of new lines here. All right, let's build them. Sorry, I still had this old hello world running. And I need to remove this one from the project. Let's build and run this one. All right, so enter float value. All right, okay, 2.03 and 5.19. All right, so the sum of 2.03 plus 5.19 is 7.22. Right, we already know how to do that. We now want to try and do this with pointers. Let me put another backslash in there, a little bit better looking output. All right, now let's convert this to pointers. So we're going to leave F1 and F2, right? And we're going to create 2 float pointers. Create and initialize. Let's do it in one step. So float star, I'm going to call this PF1 for a pointer to float 1. I'm going to make it point to F1 and star P, sorry, you can't see that, PF2. We're going to initialize that with the address of F2. So now instead of saying the address of F1 here, I can simply use the expression PF1. Instead of saying the address of F2, I say PF2. Remember, the address of each one of these is stored in here. So saying PF1 is the same thing as saying address of F1. And saying PF2 is the same thing as saying address of F2. And now if I want to, and that will store those values in F1 and F2, let's use the indirection operator. So we're going to say dereference PF1, dereference PF2. So use the indirection operator to read what's stored at. So this is the same as sum equals F1 plus F2, right? PF1 is an alias, or it's the same thing as saying F1, and PF2 is an alias for F2, right? And here we're going to use the indirection operator to print out, right, to access what's stored in memory. So if we build and run this now, and oh, I forgot standard I/O. Notice Code Blocks was kind enough to include it anyway. Let's just kill that and build and run again. All right, so it's the same program, right? I'll enter different numbers this time. And actually, let's just abort this and let's just step through with a debugger. All right, run the cursor. So F1 and F2 have some sort of garbage, right? PF1, PF2 have some sort of garbage. But now if I say next line, oh, that's grayed out. So next line, all right, now PF1 is pointing to F1. Next line, PF2 is pointing to F2 because we assigned the addresses. Now, this will then cause our message to print out. Right, enter 2 float values of 4.11 and 0.45. How's that? Right. So now, right, F1 got our 4.11, F2 got our, almost got our 0.45. You can see the rounding error associated with floating points. All right, because of the way they're stored in memory. And now let's execute our sum. This is going to say, well, let's add what's in F1 and F2, right, and store that in sum. So next line, we can see that sum has that value, and if we go to print it all out, right, we get the value of 4.56. So So same thing, right? We took one program. We took a program where we already knew how to add things with regular floats. We showed how to do it then with pointers. Like I said, normally we're not going to write short programs like this. These are just examples where you can learn how to use the indirection operator, take something you already know how to do, right, and then try to do it with a pointer. That's the best way to learn how these pointers work. Take some simple examples of things that you can already do, change them to pointers.